All right, the following diagram, there's a large Ferris wheel, diameter 100. P at the lowest point, wheel rotates at a constant rate anti-clockwise. 1 revolution takes 20 minutes. Write down the height of P after 10 minutes. So that's going to be at 100 because it takes 20 minutes to go all the way around. So at 10 minutes, it's up here. At 15 minutes, it's just at 50. Half of 100. So that's A. B. Let h meters be the height of P above the ground after t minutes. Some values are there. Show that h at 8 is 90.5. Okay. So we have 0, 1, 2, 3, 4, 5. So 10 minutes. This is at 5 minutes, 10 minutes, 15 minutes. We want 5 minutes. We want 8 minutes, which is 2 back. So it should be 9.5 from the top of 100. Does that make sense? Because this is at 10 minutes. That's a height of 100. 8 minutes is 2 minutes before. Symmetrically, this is 0 and this is 2 minutes, and that's a height of 9.5. So this should be going down 9.5. So 100 minus 9.5 is 90.5. Now if you want h at 21, that's all the way around 20 minutes and then 1 minute more. So that's 2.4. Okay, that's a 1. C, sketch the graph for 0 to 40. And this is without graphing calculator. So here's 20, here's 40, 30, 10. Okay, so at time 0, we're at 0. At 10, we are at 50. And then at oh wait, no. At 10, we're at 100. 20, we're back at 0. At 30, we're back here. Ooh, something like that. Not great. Something like that. Now, given that h can be expressed like that, find a, b, and c. Okay, so, well, c is 50 because it's the principal axis. A is also 50 because it's from 50, it's going up 50 and down 50. And then b is 2 pi over 20, so pi over 10. And the only thing is, if this is a cosine graph, cosine usually starts up here. So this A has to be negative because it's reflected. Or you could do like a transformation, but they don't say that that has a transformation. All right. Oh my God. More graphing. So just sketch it with the graphing calculator. Okay, so we have from 0 to 9. Oh, wait a second. So, all right, we need, all right, so -8 is the intercept for the parabola, and we need the maximum, which is 5, 4.5. And then at 9, we need to graph trace, which is -3.5. And we need the x-intercepts. So, which is also the intersection. So 2, 0. That 2, 0 is the intersection, sorry. And this one is 8, 0. So that's not great, but whatever. That's the parabola. All right, so then we need the sine function. So if we graph trace 0, that's going to be at 5. And we also need at 9, which is 3.5. So this just like here. Then we need, that is also, this is a max here. So this is coming down like this. And then we need the min of the sine function for -5. So like here. And then we need that x-intercept, which is 6. This is really not even. That's 6, 0. And then we just need that last thing, which is the maximum, which is at 8, 5. So it goes up, and then that. Not great. Okay. So consider the graph of f. Write down the x-intercept that lies between 0 and 3. Well, it's 2. The period of f, which is 2 pi over 4, so 8. And the amplitude is 5. G, write down the two x-intercepts. We have 2, 0 and 8, 0. And the equation of the axis of symmetry is x equals 5. Remember, it's this one. And for D, find the coordinates of the points of intersection. Well, 2, 0, good call, because I didn't find that one. So that one is 6.79, 2.90. Okay. 43. So consider this equation. For which values of k does this equation have equal roots? Back to discriminant negative. No, sorry. B squared minus 4ac equal roots. So that means the same root. So just one root. So k squared equals 4. K is plus or minus 2. That's A. B. Let f be the function that. Show this function can be written like that. Okay. So f of theta. So we want cosine squared. So we're going to turn 2, and then that's 2 cosine squared theta minus 1 plus 4 cosine theta plus 3. So 4 cosine squared theta plus 4 cosine theta, and then we've got the minus 2 plus 3, which is plus 1. C, I, consider that equals 0. How many distinct values of cosine satisfy this equation? So if we have the discriminant, so b squared minus 4ac, so that's 0. So the discriminant equals 0. That's how many solutions there are. So that's one solution. So that's 1. And then find all values. Okay, so if we do quadratic formula, I guess this factors, doesn't it? Does it? Okay, anyways. Negative b plus or minus the square root of the discriminant all over 2a. So this is negative 1/2. This is what cosine is equal to. Oh, of course, it's just perfect square trinomial. So cosine theta is negative 1/2. That is happening here at pi over 3. And we are in degrees, so that's 60 degrees. Well, it's actually negative, so it's here and here. So negative 360, that's going to be 120, negative 120. Then that's going to be 180 plus, so negative 240. And then it's going to be 120 and 240 when you go around this way from 0 to 360. All right, so given that f at theta equals c is satisfied by only 3 values of theta, find the value of c. So we need to graph this thing and find when it's got 3 solutions. Okay, so this is the graph between negative 360 and 360. We want 3 solutions. So here it's going to have, oh yeah, it's just here. Because this is 1, 2, and 3. But like here it's 1, 2, 3, 4. 1, 2, 3, 4. Here it's even 1, 2, 3, 4, 5, 6. And here it's 1, 2, 3, 4. So it's just there at the top. We have to find the max, basically, which is at 9. So C is 9.